recording. And I will share my screen and we'll get going on this topic. So there we go. Okay. Okay, so we've been going through these best practices. We talked about things from accountable positions to, use of assertions to matters with continuous integration and incremental delivery. One of the ones in which this class focuses the most is testing. Sometimes students come to me and say, if there's one foremost thing they learned from this class at the technical side, put aside the process side, which is key, it's on the testing components. They said, other classes regard them to do some testing, at least pro forma. In this case, we're going into, a lot of really deep nitty-gritty detail. And a lot of that comes from a multi-level testing approach. So maybe to keep it interactive, maybe I'll dialogue with this about this with you. I mean, so you folks have presumably watched that video. So when I say there's different levels of testing, we talked a little bit here about types of testing, UI-based, and manual versus programmatic, or I'll use a different word, manual versus automated, and within automated, UI-based versus programmatic, where you're directly calling APIs or calling things in the business logic, what have you. What are the levels of testing I'm speaking about? Okay, so you're going to discover the full horror will sink in here, because like UI testing, where it used to be that you move it by 1 pixel and it would break, right? It couldn't find the button anymore. It would press like empty space. You move by 1 seat, and I can't remember who it is anymore. Remind me your name. Tanner. Yes, thank you.
Unit testing.
You were in that seat last time, or next door. Okay, yeah. No wonder I thought your name was Sam. Yeah, Tanner. Okay. Yeah, so multi-level.
Unit testing.
Good, yeah. And generally, when we talk about those levels, and we can have finer grain. I'll come to this in a minute. I'll break that down a little bit more, but you absolutely are hitting it on it. Like, what's the difference in unit level testing versus like system testing? Can anyone say, at a high level? Yeah. Okay. A hand. Yes. Okay, names are cycling. Okay, there's a Connor with an E and a Connor with an O, but you're not a Connor, are you? Couldn't be one man. So what's your name, Ronan? Oh, Ronan. Okay, yeah. Okay. Red cap.
Yes.
Yeah.
Always red hat.
Okay, cool. Just don't make it never mind. Yeah. So Ronan.
Yeah. So I guess like systems level testing would be like end to end of the whole system, and unit level would be like just small parts of it, piece by piece, maybe.
That's right. So unit level testing, you're seeking to test a very small component. It could be at the level of a method or a function. That's sort of the classic case, and we'll be doing that a lot in this class. Preconditions, post-conditions. You're familiar with that a little bit from Mumble 270, 370?
280.
280? Okay. But it could be at the level of a class. You can talk about unit testing of a class. And there, you're testing the different methods of the class play together nicely, right? If I add this to it, I should be able to find the thing I added in the collection, right? If I delete it, I shouldn't be able to subsequently find it. I mean, that would be a kind of do the methods play together nicely. It's unit testing at the class level, not at the function level. I will expect both. Okay, so when we take talk about unit testing on. Expect, but who puts together most unit tests? Development. And I expect that. Or requires. I will demand that, yeah, no, seriously, at a serious level, I will look to make sure when you test, you commit code that you have some unit tests, no. Does that mean all unit tests come from developers? No. Testers can contribute some, but do not get in a situation where the developers throw code over and say, hey, it's your job, go write unit tests. That's not acceptable. The marks on it will reflect that it's unacceptable. At a serious level here, the testing at the unit level is something developers should be doing as part of writing code. Because they should be thinking, you know, as I write this code, how can I be confident it's working? And how can I do my job as complete if I can't run at least a simple test on this little chunk of code to validate that it actually works, right? Presumably, you know, you don't commit code that you're not confident works at some level, and this is your way of checking. And generally, I do like to recommend you think about putting together a test even before you write the code. You know what it's gonna need to do, and if you're testing a function, you can actually do it before you write that function, right? I'm not absolutely gonna require that strictness of TDD, but I do expect in your pull requests that you say, like, these are some tests that are together, okay? Now, those would be at the level of a small piece of the system, be it a function or a class or, you know, a small element of an API, a couple functions that work together in the API. Maybe it's an endpoint and you're confirming the endpoint works properly. Connor with an E? Okay, like some things stick, you know? Just watch, it'll pop up the other ear like while we're in class. Okay, it helps you're in the same position.
Yeah.
Passes
Charging
this-
a lot, so I'll probably be here.
Okay, good to me. That's unit testing level. When I talk about system tests, you hit on a pretty good description of it. But what are you testing there? You're testing. Yes, I'm not expressing displeasure with you. Yeah, name?
Aladdin.
Aladdin?
Yeah.
Okay, cool. That's great. That's really helpful. Yes, thank you.
System testing a feature.
Yeah, you're often testing a feature. You're testing at a level that might deliver functionality to the user, right? Like a use case sometimes, or user story. You folks cover user stories. Yeah. Do you cover user like use cases in a more classic way? Yeah, okay. So both of those describe sort of context where you're delivering value to the user at some level. Maybe it's a use of a feature, maybe it's a couple features that they accomplish some task, right? With use cases, and you're testing that sequence. You know, maybe you're loading the document or modifying this, you're saving it, and you validate that when you load it again, you know, you get the same thing. Obviously, I'm not picking on an example that's likely to come up exactly in one of these projects, but that's the idea. And then, you know, what a chunk of user delivered value would be for the user to accomplish something will differ project to project, but it's the user accomplishing some task and you're testing at that level, right? And often that's involved in, does anyone know there's a special type of testing at the highest level that are system tests, but they're designed to demonstrate a system is ready. It's fully baked. It's ready to be delivered. And anyone know the name there? It's a big deal in some industries, like the pharmaceutical industry, the whole cottage industry, for doing this sort of testing. Yeah, name back there. Bolin. Okay, Bolin? Yeah. Yes, awesome. So alpha and beta are as they're further along in the development process. the truth is, beta testing is as much a marketing oriented type of testing, like where you're trying to raise awareness and excitement about your project and get power users using it and sort of talking about it as much as it is, even more so than it is rigorous testing, because a lot of the times people who don't like the beta test won't let you know, because they just say like, well, we put it in terms often less common than this, but they say like this product is not yet ready. And they won't actually bother reporting it. So we'll talk about beta testing. It can be very useful. Don't get me wrong. It can be very valuable. And alpha testing can be useful if you set the expectations right and you use it for the right purposes. But it's not an internal test activity which you look to demonstrate to give you a really firm sense of, is this system ready for shipping? There is a type of testing that gives that sense. What is it? For acceptance testing, for production ready system. And Trushank? Yep. This side somehow, it's like my right ear or something. And remind me your name. Alex. Alex. Okay. Cool. If you folks continue to sit in your teams, I better change. So acceptance testing is a type of system testing that has specific criteria associated with it. Is this fully ready for production? Be it, shrink wrap software, less common these days, via going live on a website, be it putting it up on the App Store or on the Play Store for Android devices, or up in the Meta Store, mobile for Oculus or whatever, right? So acceptance testing often comes with like strict criteria as to, it has to pass these tests to be viewed as done. That's going to be less central in this class. I'm not going to, in part because it's time boxed. Like, it has to be done by a certain date. And we all know what that date is. So I'm not going to strictly require that, although it is good practice to talk like, when is it ready for a given deliverable to be given to the test team in your project? So Connor with an E.
Yeah, what would the difference between acceptance testing and coverage testing?
Okay, coverage testing, great question. So coverage testing is an extremely valuable form of testing that involves assessing the breadth of the reach of your test suite, right? Across the system as a whole. And so you're doing, it's quite different from like unit testing, which is focused on, every given unit test is focused on one piece. This is operating at a higher level, right? It's operating for a whole suite of tests. What fraction of the program, what fraction of the statements did they reach? What fraction of the features are tested by them? What fraction of the code blocks are reached by it, or the functions that are reached by it? You can quantify it in different ways. In different generations of coverage testing have used different ways of quantifying it. But the basic idea there is like, if your code isn't even reaching some parts of a system, you can't say without a red face that you've really seriously tested the system, right? If there's whole areas of the system, 50% that are not even reached by your test suite, then you've got work to do, right? And by the way, that's work from testers and developers. Both have work to do. I'll come back to that point. But the point is, it's a way of assessing particularly what's our vulnerability, what are the things we don't know about in terms of the areas of the system we haven't reached, so you can expand the reach of your testing. And generally it's testing automated tests, right? Because it gets really tedious if you try to address low coverage by having a massive manual test effort every time. Generally, you want to track coverage over time. And you can have bug parties after coverage, that's good, and find areas that are gaps, test gaps. And have a bug party that focuses a lot on those, that's very good, I will reward that, I think it's excellent. Invest in bug parties early and often, take it from an old man. But generally, you're gonna be running these coverage tests frequently. And this is part of what might be going on in a full build, like remotely, that you can't afford to do locally. And you might do it with regression tests as well, right? To really see what you're reaching. And it used to be more specialized. These days, some version of coverage testing have made it into a lot of routinized testing, like for React Native and React. You have it built into Jest, for example, some ability to do coverage testing, whereas it used to be the province of things like Cobertura and more specialized testing tools. But coverage testing is something I expect to be done as part of this class. It's routinely accessed, and a lot of the time it's rarely done with the automated test environments used anyway. Yeah. Name.
It's Colin.
Colin.
Yes. I was going to ask the difference between, or if they can be combined even, regression testing and unit testing.
Yep.
And kind of how they could be integrated with the process.
Yes. Good. So regression tests. Regression tests are all about finding that the system doesn't regress. It doesn't go backwards, right? And that can mean an old bug reemerging. Or it could mean a function, a set of functionality, like a feature that used to work no longer. This may sound like really kind of arcane or weird, like, but can you give me some circumstances where each of those might happen? Like, why might a bug, a defect that was there before and got fixed, why might it reemerge? Yeah, so, yes, Nate? Jason.
So a bug may reemerge, let's say you write some code and it overwrites, it's like a variable or a function name.
Okay, so it is true that you could write code that leads to accidentally blocking out some code that is critical for this, and it happens to be a bug from earlier. So that is an important way in which it can reemerge. Anyone else ideas? Yes, Nate? Ron. Roland? Ron. Ron?
Yeah.
Okay. Ron and roll. Yeah. Yeah, okay, introducing new technology. I mean, sometimes introducing a new technology could cause a bug to reemerge. I don't rule that out, like if there's enough memory thing, and now you have a new technology which consumes memory on the Android phone, and it causes this out of memory thing you fixed to now occur again. So it is possible, but there's a very common way in which you can reemerge. Alex?
Would it be like if one developer sees a bug, they fix the code, but they realize that now the code needs to have a certain constraint so that the bug doesn't happen again. And then the developer comes along later, they think, I don't like this constraint, I can change it to remove it, and then they reintroduce it.
That's right. They failed to sort of document why this certain component is needed. Like, I don't want you putting in comments for me, as the motivation for putting in comments, just to get the grade. Look, you put in comments to prevent those things from happening, so that others who look at your code won't make, understandable oversights and think, oh, this can be simplified. This is way too ornate. Like, we don't need that constraint. That's artificial. We can make it faster. It's relaxing that, and then. They didn't realize why it's intricately related to factors. Similarly with like preconditions, postconditions, right? Like if you don't document those, you may break them, right? You pass in two indices without realizing the first has to be less than the second, and you think like me in angel order, it will figure out which is smaller than which and do it accordingly. it ain't so, right? So this can happen. How about another one? Yes,
Well, I guess I was gonna kind of say the same thing, but just from experience, when I would write like, pages and pages of SQL code for like a production database. And I would develop these queries and I would come back 2 years later
yeah,
and have to relearn the whole thing because, well, surprised I didn't document it for myself. That's a nightmare, and that's where things can break pretty easy in experience.
that's right. So you went through that too.
Yeah. Microsoft SQL, yeah.
I'm sorry, yeah, but, painful. It can happen less than 2 years.
Yeah.
Yeah, I feel your pain, Rob. Okay, so those are good. Merge conflicts. Why do I say merge conflict? Like, why can that cause remergence?
If somebody could have an old, even somebody got like an older version of a file they pulled, and when they didn't pull the
Yeah.
new version.
Yeah.
And they put the version that hadn't had another bug change back to production.
Exactly, yeah. So excellent. All these are good reasons you could have reemergence of a defect. That's a lot more, that's a very plausible situation. How about a feature stops working? Could that occur? Let us count the ways, right? You add new features that break these other ones, that generalize assumptions, that allow new functionality that didn't used to be allowed in terms of what can be where, and it breaks old assumptions and code. This can happen in many, many ways. And I want to highlight, like, when things that used to work stop working, that's really bad for the user, right? Not getting, like, a user wants a feature, and it doesn't work properly, they may be disappointed, but their whole workflow doesn't depend on it, right? They're hoping to work. You know, they can do things useful, and it's some loss, right? I won't pretend it's not, but what's much worse is their whole workflow is around a certain feature. They've been counting on it. It's part of their day-to-day work, and then it stops working. That's like A1 bad. That's not only A1 bad, it's A1 frustrating and problematic, right? You delivered negative value, right? You not only have not delivered value, you delivered negative value, right? So regressions are these, type of tests that have these certain goals, and often they will be unit level tests. Not always. Like there are regression tests that are system level tests. Don't get me wrong. But a lot of, like, by number, a lot of the regression tests will be unit level tests, because when you may remember this from last time, when you put in a fix for a defect, one of the best practices is you do what? You remember from last time? You check it in with when you fix a defect, you put together a pull request that documents what you fixed, but accompanies it by if a full build has to occur, yeah. But it accompanies it by, I'll give you a hint, it begins with a T, it ends with a T, it has an E and an S. Okay. You put together a test that demonstrates it's fixed. And where does that test go? It goes into the rejection suite, right? To make sure that doesn't break. And this is how a lot of regression tests appear. Is they are contributed as part of fixes. Not all, but quite a few. And often there's this test gap between, like, a current suite of tests that are run every build and the entire cumulative test suite that includes all these regression tests. Because regression tests, there could be, in a big site project, there could be 10,000 plus project. A year or two after we started shipping a smartphone-based system for Android, we had around 1,000 tests in place, something like that. And so, the regression test set can build up to very large levels, at a level that for real world projects become unlikely you could run it every build. And then you gotta you gotta, have a regression test that might be run nightly, for example, regression test suite, not every build. I was on, I'll let it know. You'll sense the full horror of my age. So I was privileged to be on, well, maybe the first team in the US, maybe worldwide, using daily builds. The Microsoft Excel, back in the 80s. And we were pioneering some of these incremental delivery, daily build, and what eventually became known as continuous integration. Back in the 80s. And it was an awesome team to be in. And one of the reasons is they were taking software development processes seriously. Okay. So regression tests were a big part of what they were doing, and they would do them on the daily build. It wasn't build every time you committed. Back then it was what, SCCS or RCS, these version control systems, and we couldn't run it every time we built. These days you can actually run much larger suites. Generally though, unit tests part of regression aren't that expensive to run. What's really expensive to run is like system level tests through the UI particularly. And like random testing against it, etc. Okay. So other questions that might have, I want to hit on a point that I kind of put in the parking lot for a moment, but I want to ask other questions people want to ask that came out of that video. Yes, Alex.
I guess like with the build master.
Yeah.
It would be nice to see like an example of a workflow including those types of tests.
Sure. Oh, yeah. I'm glad to do that. You mean like take a look at what the YAML files might look like for different projects that would show the GitHub Actions flow that would run the test suites, etc.
Yeah, and just like see like what would a developer who's working on it, like,
Yep.
what would their process be going forward?
Yeah, I'll do that, and that's something Alex could speak to in that lecture. Yeah, Connor with an E.
So for pull requests, is there like a standard, like, something I've seen they have templates for what they want their pull requests to look like? Is there like a proper standard template that people often use, or is it?
I could recommend one.
Okay.
I mean, there's no standard
Right.
for it, but there are best practices
I've
for
seen
it.
that look nice, and I feel like it just makes it easier to.
Totally.
Yeah.
Totally. They're associated with Git flow. Some people have put forward like certain, like this is what a good pull request would roughly look like. Like, it would have this type of information, etc.
I think I've seen though that they'll, if you don't have a specific format, it like won't accept your pull request at all.
Yeah, that's right. Yeah, you can have validation that actually checks the format of the pull request and will reject it. And this is something that Alex again can speak to. And that's kind of like style checking, but on the pull request, right? And it saves the reviewers time, right? Because they don't have to go back and re-review the same thing as it gets like missing things added to it, etc. Right? Yeah. Okay, I wanted to talk about the role of the developer. So we've said that, look, developers contribute a lot of the unit tests. I mean, only originally a lot of unit tests was contributing code. But there's another key way that developers help testing in the system. And it goes by the word testability. And we're going to have a sort of a module, a small module. But I want to introduce the idea early, because I want you to have it in mind when you spec out like how your system would evolve, how would you keep your system robust? Look, in this class, I do not require a full architecture to be laid out up front. I don't require a complete design of a system from the low side to the high side to be put into place for this class. And I do that because value is delivered incrementally. You don't know exactly what features will be required by the time ID 3, 4, 5 comes around. And in putting in place a complete architecture now, would risk irrelevance of a lot of that architecture. Like by the time you actually do those things, you're actually not implementing that feature after all. You're doing this other feature, or this other issue has come up. So I don't require that. What I do require is thoughtful planning that will keep the project able to evolve nimbly and be extensible. And that requires certain types of best practices, like separation of interface from implementation, like putting in place layers that separate things like the data layer from the business logic layer from the UI layer, or with multi-tier architectures that make use of certain standards like REST, representative state transfer, or that have a way of making sure that there's an API that will stay more stable even if the existing implementation of it changes, or if you swap in testing-oriented components rather than the real thing. So there's certain approaches you folks have learned, certain practices technically. I've listed a bunch of them. Encapsulation is another one. That separation of concerns. Do these things ring a bell? You may have heard of the solid principles. Those are familiar to you.
What does it stand for again? I don't remember that.
So these are principles associated with like object-oriented design,
Right.
that state that a system should have a set of properties associated with that. And I would need to remember the details, but I know like some it should be with the D, I think you have, is it durable? What's that? Dependency inversion. Okay, so you don't have X calling Y, you have basically a pointer to X provided so that Y can call it. And so you can provide a different implementation of X by substituting a different dependency. Yeah. These things should be independent in terms of their design, and they should be designed in a way that are coherent internally, but allow for external systems to sort of call off for a certain type of functionality. And anyone want to read that out? I forget the acronym. Yeah.
Solid, single responsibility.
Single. Okay. Good.
Open closed principle.
Open closed. Yeah.
Risk of substitution.
Good. Yeah.
Interface segregation and dependency inversion.
Yeah, okay, good. So interface-based programming is part of it. Liskov substitution principle has to do, of course, with the ability to have type-safe use of polymorphism. You folks encounter that? What is it, 270 or 370 these days? 270. So you could substitute one thing for the other in a type-safe way in the presence of polymorphism, that a subtype has to adhere to the same properties as the supertype. Right. And open closed principle has to do with the ability to evolve it over time in ways that are safe. There's also some things not covered there, like safe subclassing that we sometimes cover within this class. That it's actually not just safe subtyping. Let's go substitution principles about safe subtyping, using in the presence of polymorphism, where you can pass in a subtype as if it's an instance of a supertype. You have to be able to do it in a way that the reasoning for the supertype holds for the subtype, where safe subclassing has to do with inheritance. So we may talk about these in this class as the semester goes by, and also the acid properties, the atomic, consistent, independent, and durable, which are key to transactionality and safe support for safe concurrency. But there's a key need with testability for developers to make their system able to be tested easily. And that's what I'm looking for you. And again, it's about like separation of concerns. Open closed is a good example of it. Let's go substitution principle. By extension, it's dealing with types, which are really about the contracts involved, like the properties they guarantee. And that also is a good component of it. Separation of concerns into different layers. These are things I'll be looking for which enhance testability. There are other things that enhance testability besides these good design principles. Anyone want to say, like, what helps with test to make a system testable? Alex mentioned some things earlier by extension. Figure of the testability. Good. Sorry.
How you code it, like how you code it.
Yeah. Clean coding. Dividing things up. So dividing things up into small chunks that have clearly well-defined sort of intentions behind them. They have a certain job in life that they do. That's very well-defined. Sorry? Documentation can really enhance testability. Using mocking tools or providing interfaces that allow for mocking. Is mocking something that's been covered in your classes? Okay, this is very tied in with the issue of dependency injection. Because often one of the most common ways to get supported is through dependency injection or inversion of control, where you substitute in kind of a doppelganger. You substitute in something that looks like an X, but whose job in life is to allow for testing against it. And we'll talk about that. I'll cover it more if you haven't seen it before. But support via use of a mocking framework is something we look for in this class. I'll be looking for the teams to try to use mocking where possible. And it basically allows you to test one area of the application at a unit level. Bring my own. So look, the difference in, so I was saying, we have an area of the system we want to test, right? Call it A here. Maybe it calls off to B, right? In C, and D to do its job, right? These may be libraries, these may be other areas of the API. And if you want to test this at a unit level, that may seem really difficult without testing, B, C, and D here. Oh, we got two B's. Okay. So with mocking, what you do is you mock these out. These are mocking interfaces. This is sort of a pretend B, this is a pretend D, this is a pretend C. And it's not that nothing's there, something is there, but what's there is an automatically substituted doppelganger for C. It's a pretend C whose job in life is to observe that it is being called, possibly record information to a log or what have you, possibly check certain preconditions. And possibly return certain random values or certain fixed values. And these mocking interfaces help confirm that A is working, even if these aren't even implemented yet, B, C, D, right? Because that's another challenge. How do you test A if these aren't implemented yet, right? You want to get testing in for A as soon as possible, unit testing. You're a developer, you want to contribute, you mock these out. And then you can test A independent of these. And that will be really unit testing of A. And then unit integration testing of A would involve testing A against the real implementation of C or real implementation of all three of the B, C, D. So mocking lets you, without writing code, just saying what properties should be guaranteed when A crosses C in terms of the methods passed, or that it should only be called once, or it should be called with non-null values or whatever. It should be called 2 or 3 times only, no more than 3 times. You can mock these out and say, let it be mocked, and it allows you to test A in isolation. Does that make sense? So that's an element of testability. Yeah.
How would you defend like a even in whatever language it's Java or something, like a mock class or whatever it may be. Like you create like a real class, it's supposed to have very much code to return values, or is it called like class mock or something? What's the?
For Java, a common tool is JMock to do it. I think for JavaScript, if I'm not mistaken, it's Mockito. There's also JS mock, I think. I may be forgetting that, but JS mock for JavaScript. So different platforms actually have specialized mocking tools. Okay, now that's not to say you should be a slave to your tools. You shouldn't be. You should be able to manually perform mocking, but that would involve using solid principles, separation of interface from implementation. You by virtue of having an interface, this would not, you to call this directly, will call this as represented by its interface, right? It will call this through an interface, and that allows you to substitute out for C some other thing whose job is that you've custom written to check, is this true, you know, and make sure that it's sane, that it's being used properly, and returns a sensible value, maybe from a database, for example. So when it comes to testing your data layer, like this is really key, right? You don't want all your tests. My goodness, the unit tests of the data layer or business logic have to go to the real database. You want to be able to mock out a database so that other things can be tested without going over the network or whatever, or else tests will take a lot longer than they have to. So separation of concerns into different layers, data layer, business layer, et cetera, is key, but separation of interface from implementation allows swapping this out for an implementation of job is to enable mock. Does that make sense? What these tools allow is doing that at least some of the mocking tools, and many of them will allow doing it declaratively. In other words, you don't even have to write that code. You just say, you know, make there be a mock of this that checks these properties through this that uses this interface, and it will make it so. Okay, and then you can write against that. You can write tests against that mock.
So how often will we be like updating the parameters in the runner so that as things evolve in the system? Like just because, like I said, it moves up the B, by the time it gets to like the build, it just kind of.
Well, you would have test suite. Some of it is going to use mocking. By the way, you folks can start packing up and so on. You know, you've got to get over to other buildings. But like you're going to have a test suite. Some of it can use these mocking technologies to conduct those unit tests and so on. But then others will maybe operating against, you know, manually defined mocks of things, which you've written bespoke to sort of test things. And yet others might be running system tests of all these things, you know, against BCD and fully implement. And so all those should be the test suite. But what I think you're putting your finger on, Bob, is that test break. But yeah, when you write against something, it can break if that changes. And this is one of the reasons when we have an interface, like an API, we want to evolve that slower than the implementation, right? And that's one of the reasons we separate the two, because we're evolving the implementation all the time. And you want the interface, yeah, it will evolve inevitably, but you want it to evolve a lot slower so that all the code that calls through the interface will break whenever you change the implementation. That makes sense, right? It's kind of like if you use FedEx, you don't want to be counting on the particular people you've dealt with at FedEx. Every time you change, you have to do a new, you know, how you do business with FedEx. No, you just want to say, I want to be able to call FedEx, whoever the driver is they have these days, whatever plane they have from the South Peter Airport. You don't want to have to be involved. That's their business. That's separation of interface from the. Okay. Okay, good discussion. Let me know how I could help on any project matters. Thanks.